All right, today we are going deep on a really critical safety alert for one of the most popular jets in the sky, the Airbus A320. Now, this isn't some scary story about a disaster. Actually, it's the total opposite. It's the story of how a potential disaster gets stopped in its tracks, long before an airplane ever leaves the ground.
So what's the secret, really? I mean, what actually keeps a plane, that is, the workhorse of global travel, so incredibly safe, day in and day out? Is it just the pilots? The incredible engineering? Well, yes, but it's also something much, much bigger.
It's this incredible, global system of, well, constant vigilance, always looking for problems before they become problems. And a perfect example, the one we're diving into today, is something called Proposed Airworthiness Directive 25-140. It comes from EASA, the European Aviation Safety Agency.
Okay, first up, a critical A320 alert. This new directive basically puts one very specific, very vital component on the A320 family right under a global microscope.
And listen, the scope of this thing is just massive. We're not talking about a small batch of planes from a certain year. Nope, this applies to the entire A320 family. The A318, the A319, the A320, the A321, every single one, regardless of its serial number. That's literally thousands of airplanes all over the world.
So, what's this all about? Let's get into the hidden risk behind the fire panel. We're going to uncover the potential defect, and, more importantly, why it matters so much.
Okay, so what exactly is a fire panel? Well, you can think of it as the command center for fire safety on the flight deck. It's how the crew can see if there's a fire in an engine or a cargo bay, and it's how they activate the fire extinguishers. Basically, in an emergency, this thing is absolutely critical. Its function is non-negotiable. Right, so what's the potential unsafe condition here? What's the specific thing that got the regulators worried enough to issue a directive like this?
The big concern is that a potential defect could stop the fire detection or the fire suppression systems from working properly. To put it really simply, the one thing you absolutely need to work in a fire emergency might not. And that right there is a risk the aviation world is just not willing to take. Period.
And what's really interesting is how precise this is. The regulators have drilled down to specific part numbers. This isn't some broad, vague warning. It's a totally surgical strike, aimed at a very specific set of components that could be out there in the global fleet.
Yeah, think of these part numbers just like a serial number in a massive recall for a car. It lets the maintenance crews know exactly what to look for so they can find any potentially faulty part with pinpoint accuracy. The goal is simple: find every single one and check it. So, identifying the problem is step one. But how do you actually go about fixing it across thousands of airplanes? Well, that's where we get to the engineer's inspection plan.
And this quote from the EASA directive lays out the game plan perfectly. It's a really methodical process. You inspect the panels, you repair them if you find anything wrong, and then, this is key, you re-identify them. And it's all done by the book, following what's called a vendor's service bulletin, which is basically the super detailed instruction manual from the manufacturer.
So the whole process is really a three-step dance. First, you've got to physically inspect every single one of the affected panels. Step two, if you find the defect, you have to repair it exactly according to the manufacturer's instructions. And then step three, you re-identify the part. That's kind of like giving it a new label that says, yep, this one's been checked and it's good to go.
And this is how they track everything to make sure nothing falls through the cracks. It doesn't matter if a part starts out as uninspected or if it's found to be defective. It has to go through the process outlined in that vendor's service bulletin. In the end, there's only one acceptable outcome: compliant. That's it. It's the only way to guarantee every plane is up to standard.
But a directive like this isn't just about the hangar. It creates these huge ripple effects for the airlines. So let's talk about the hidden costs and challenges that go way beyond just swapping out a part.
Really, the impact on an airline boils down to three main things. The biggest one, by far, is just operational disruption. I mean, you have to pull planes out of the sky. Then, of course, you've got the financial costs for the work itself, and on top of all that, there's a mountain of paperwork and management just to track compliance across the whole fleet.
And what makes this so tough for airlines is that it's unscheduled maintenance. See, scheduled maintenance is planned, it's efficient, you work it into the schedule, but this forces you to pull a plane from service when you weren't expecting to, and that creates this massive logistical nightmare of delays and cancellations that can mess up an airline's entire network.
But here's the thing, and this is probably the most important point of all. It's really easy to look at this and see a problem with an airplane, but that's not the real story.
The real story is that this whole situation is proof that aviation's proactive safety net is working exactly like it's supposed to.
I really want to land this point. This is not a story about something failing in the air. It's a story about a potential failure that was found on the ground and is now being systematically wiped out before it ever gets the chance to become a real incident. That, right there, is proactive safety in action.
And this kind of thing doesn't just pop up out of nowhere. It's part of a well-oiled process. An issue gets reported, then the regulators like EASA draft a plan. But then, and this is super important, they get feedback from the airlines and manufacturers before they issue a final, mandatory rule for everyone.
And really, the key to this whole system is right there in the directive itself. It's about collaboration. The entire safety net relies on a constant feedback loop. Engineers, mechanics, airlines all reporting what they find. It's that shared information that makes the whole industry safer for everyone. So, here's the takeaway. This system found a problem before it could happen. The next time you step onto a plane, just remember that there's this massive, invisible safety net that is constantly working in the background. And it kind of makes you wonder, right? What other invisible safety nets are out there, protecting us in our daily lives that we never even think about?